Welcome everyone. The question that is shown on the screen, it came in the CBSE Physics 2026 question paper. In which of the following total internal reflection does not occur? Option A, twinkling the stars, brilliance of the diamonds. Option C is optical fiber, and option D is reflecting prism. At once I can say the answer is a twinkling the stars, but we will discuss it from the basic. Okay. This is the interface of the two media. Let us say this is the media or refractive index mu2 and this medium of refractive index mu1, and mu2 is greater than mu1, then mu2, that is the medium 2, we can say that is the denser medium and medium 1 is a rarer medium. So if the light ray try to refract from the denser to rarer medium, then obviously you know that the refracted ray will bend towards the normal. Okay, so this is the angle of incidence. Now if you increase the angle of incidence, then at a particular value of angle of incidence you will see the refracted ray, that is the refracted ray. If I say this is my I2, the refracted ray makes an angle 90 degree with the normal, that is the angle of refraction is 90 degree. Okay, so at this particular case, if I want to write it down, that what is the Snell's law, that is mu2 sine I2 equal to mu1 sine 90 degree. So sine 90 degree is 1, so sine I2 is equal to mu1 divided by mu2. So you can say sine I2 equal to 1 divided by mu2 divided by mu1. So that is 1 divided by 1 mu2, that is refractive index of the medium 2 with respect to the medium 1, and this I2 is called this I2, that is sine inverse 1 mu2, this thing is called the critical angle of incidence, the particular value of angle for which you will get the angular refraction 90 degree. If you make the light ray incident at an angle greater than that of the critical angle of incidence, the light ray will not refract, the light ray reflect only, and that particular angle is called that phenomena is called not the angle, the phenomena is called the total internal reflection. So the first case is the brilliance of the stars. Okay, so obviously if you say this is the real position of the star, okay, then the light coming through the several atmospheric layers, okay, and we have observed that if I say these are the layers of the atmosphere, the refractive index is increasing, okay, so the refraction occurs, we can't get the light ray at its real position but at the apparent position, and it is continuously twinkling. Okay, it is continuously twinkling, or we can say brilliance of the stars, because the refractive index of these layers are continuously changing. Okay, that is the reason of the twinkling of the stars. Here the light ray is entering from the rarer to denser medium, because the refractive index is increasing as we go downwards. So there is no question of total internal reflection. So this is our part A, option A. Here the total internal reflection does not occur. So let us take the next part, that is the part B, that is a diamond. In case of diamond, the light ray basically incident here, that is a completely, we can say it is entering from the air to the diamond. So it is total internal reflection does not occur, simply refraction occurs. So after that it enters into the diamond. Okay, when it try to incident here, it incidents here, and after that what will happen, when it try to refract outside, here now the total internal reflection occur, and it gets inside, trapped inside. Here also simply the total interreflection occurs. What is the reason? Because the light is coming out from the denser to rarer medium. So again total interreflection. So these way the light is trapped inside, and that is the cause of sparkling of the diamond. So total interreflection occurs when the light is coming out or light is trying to refract from the denser to the rarer medium. Next is the our optical fiber. So this is an optical fiber. So in this optical fiber, the core of the optical fiber is made such that, okay, the inner core is kept of high refractive index, and outside there is an air. So light is try to refract. When the light is incident on it, the light is try to refract from the denser to rarer medium. Total interreflection occurs at each and every point, and then what will happen? We are going to see that without any loss of information, it is transferred from one end to another end. Let us say from one end A to end B. It may extend up to several kilometers without any loss of information. Next, it is talking about the reflecting prism. Now they are talking about the reflecting prism. Okay. So several prisms are taken. It is a 90-degree prism. Angle of prism is 90 degrees. It is 45 degree. Okay. So if this is the object, if I say if this is the object, okay, then light ray coming out from the object incident on this point and this point. Now we try to refract from the denser to rarer medium, and we know that from geometry it is very easy to be understood that this angle is 45 degree. Okay, most of the cases it is made up of glass. So we know that the critical angle of incidence for the glass, it is 42 degree. So the angle of incidence is greater than 42 degree, so it is around 45 degree. So we can say total interreflection occurs here also, in this case also, and in this case also. In both of the cases total interreflection occurs. Now for the coming to the second figure, discussion of figure 1 is done. Coming to the second figure, now here also if the light ray enters normal incidence at these 2 points, and after that what will happen? When it just enters here, what will happen? Again total interreflection, because here also if you calculate the angle is again 45 degree. Here also again total interreflection. So total interreflection without a loss of information, we just inverted the image. Okay, just see, we just inverted the image. Next is, if I allow this surface of the prism, again you will see at this point and at this point the total internal reflection occurs, because here the light ray try to refract from the denser to rarer medium. So again here we are able to invert the image. So in case of the reflecting prism, in case of the optical fiber, in case of the sparkling of the diamond, okay, we are getting the example of the total internal reflection. But in case of the first option, that is the twinkling of the stars, it is not due to the total internal reflection, because here the light ray is entering from the rarer to denser medium. So there is no question of total internal reflection, and the twinkling is due to the change in the density of the different layers of the atmosphere with the temperature. So refractive index is changing, and that is the cause of the twinkling of the stars. So here option A obviously it is the right answer, and here total internal reflection does not occur. Thank you all of you.